Alright, so today we're gonna be going over antiderivatives. So antiderivative is it's kind of just the opposite of derivatives. It goes into integration and essentially calculus too. So for now, think of antiderivatives as literally the exact opposite of derivatives. So let's say you have a derivative of x to the n power. In order to find the antiderivative, instead of subtracting 1 in the exponent, you would add 1, and then you would divide it by the added 1 exponent. And let's say you have a function 1 over like x plus 1. The antiderivative of that would be ln is x plus 1. Because if you remember, the derivative of ln of x plus 1 would be 1 over whatever in the inside times the derivative of the inside, which would be 1. And same thing with trig functions. Sine of x, derivative of that is going to be cosine of x. So the antiderivative of cosine of x is going to be sine of x. But let's say we have x to the fifth power. Let's also put a 2 in the front. So let's find the antiderivative of that. So antiderivative of that is going to be x to the sixth power because we're adding 1. And that would be divided by 6. It would be divided by our new exponent. And that would give us an answer of 1 over 3 x to the sixth power. And let's also do the antiderivative of 1/2. So the antiderivative of 1/2 would be, we would add 1 to the exponent, so it would be 3/2. And then we divide it by the exponent. So if we divide it by 3/2, it's going to be times 2 over 3. So that would be our derivative or antiderivative of x to the 1/2 power, or square root of x. So let's try out some few problems here. So let's take a look at number 1. So number 1 is f of x is equal to 0. So in order to find the antiderivative of a constant, we would add an x to it, since it's a function as of x. If it was f of z, we would add a z to it. So instead of, you could think of it as 6 to the x to 0 power. That is essentially the function f of x. So if we find derivative of it, we would just add 1 to 0, and we put it over 1. But over x over 1 is going to be x. So you could kind of write it out like that to visualize it, but essentially antiderivative of that is going to be 6x. So you would add an x to it in simplest terms. And b is going to be 3t squared. So to find the antiderivative, we're going to add 1 to the exponent, so it's going to be 3. And we're going to divide by 3 as well. So 3 over 3 is going to be 1. So we're actually going to be just left with t to the cubed power. And those are going to be answered for number 1. Let's take a look at number 2. Number 2, we have 2x. So in order to find the antiderivative, we just add 1 to exponent. This exponent is going to be 1. So we just add 1 to 1, it's going to be 2. And we divide by 2. And 2 divided by 2 is going to be 1. So we have our final answer as x squared. And then let's look at this one. This one is going to be negative 1 over x2. We could actually rewrite this as negative x to negative 2 power. And so when we find the antiderivative of this, we're still going to add 1, which would mean that the exponent would be a smaller number, or a bigger number on the negative side technically. But if we do that, we're going to have negative x to the negative 1 power divided by negative 1. So we have two negatives, that would just cross out, we would have a plus. So if we simplify that, it's going to be just x to a negative 1 power, which is also 1 over x. So that would be our antiderivative of that. And now we have function h of q is cosine q. So we know a derivative of sine is cosine. So the antiderivative of cosine q is going to be sine q. Sine q. And then we have e of x. So as you remember, derivative of e of x is just e of x. So the antiderivative of e of x is going to be just e of x. Alright, so let's take a look at these few questions. So these few questions we're given the second derivative, and we have to find the function, which is going to be Basically that we have to find the antiderivative twice. So for the first number 29 is we're going to put the exponent to second power 24 divided by 2, and that's going to give us 12x squared, which is going to be our f prime. We want to find f. So we just do antiderivative again. That's going to be x3 now over 3, and that's going to be, if we simplify, it's going to be 4x cubed. So that's going to be our f for number 29. For number 30, we have t squared minus 4. So we find derivative of that, or the antiderivative, it's going to be t to the third power over 3 minus 4t. And now if we find the antiderivative again, it's going to be t to the fourth power minus 12, because we put it over 4, and so we're going to have 3 times 4 in the denominator, and that's 12. And we're going to have we're going to have t squared 4 over 2, and that's going to be it. So if we could simplify this, it's going to be t to the fourth power over 12 minus 2t squared. And that would be our answer for number 30. Number 31 is going to be our first antiderivative is going to be x to the fourth power, and then 4 over 4, and then we have plus x to x squared 24 over 2, and minus x, because or it would rather be 1x, but we don't really need to write the 1. And we could rewrite this and simplify it. So these 4's would cross out. We would have x to the fourth power plus 12x squared minus x. And now we need to find an antiderivative again. That's going to be x to the fifth power over 5 plus x3 over 3 and times 12 minus x squared over 2. If we simplify this, we're going to have a final answer of x5 over 5 plus 4x3 and minus x squared over 2. And that would be our final answer for number 31. And now let's bring number 32 down here. So we have 6x minus x fourth plus 3x to the power of 5. So if you find the antiderivative, we're going to have 3x squared. And I'm going to pre-simplify just so we don't have to go through all that. It's going to be 3x squared minus x5 over 5. And that's going to be plus 1 half x6. And that's the f prime. Now we want the antiderivative one more time. So we're going to have x3 and 3 over 3, which is going to be 1, minus x6 over 30. And that's going to be plus x7 over, that's going to be 14. And that's going to be our function, or double antiderivative for number 32. And for number 33, let's create some space over here. So number 33, we have 2x and 3x, 3ex. So for the first antiderivative, it's going to be x squared, and it's going to be plus 3ex, and that's going to be your first antiderivative. Now we antiderive it one more time, which is going to be x3 over 3 plus 3ex, because the derivative of 3e to the power of x is going to be 3e to the power of x. So as you antiderive it more, it's just going to be the same thing. So that is going to be our function for number 33. Alright, so I want you guys to try number 5 through 11. So for these, you're going to find the antiderivative, and then you're going to add a constant of integration, which is going to be plus c at the end. Because when you find the antiderivative, you're going to have a constant that you don't know what it is, so which is going to be the plus c at the end. So you could pause the video and try that out. Alright, so let's take a look at number 5. Number 5, we have function f of x is equal to 4x plus 7. So we find derivative, it's going to be x squared, 2x squared, plus 7x, and then that's going to be plus c. And now number 6 is going to be, if we find the antiderivative, it's going to be x3 over 3 minus x squared, and then times 3 over 2 plus 2x, and then that's going to be plus c. And number 7 is going to be x to the fourth power and times 1/2, and that's a power, x to the fourth power right there, minus x3, 2 over 9, and then that's going to be plus x squared times 5 over 2. A good rule is to figure out the exponent first, and then write out the fraction is multiplied by, so that you don't really have any mistake. So we're going to go into number 8 now. Number 8 is x to the sixth power minus x to the fifth power times 8 over 5, and minus x to the third power times 3, and plus c for both of these. I didn't write plus c for that. Number 9 is going to be, we can multiply that out first. It's going to be 12x squared plus 8x. Now we find the antiderivative, which is going to be 4x cubed plus 4x squared, and plus c. Now number 10 is going to be, we can multiply it out first, which is going to be x squared minus 10x and plus 25. Find the antiderivative of that. It's going to be x to the third power over 3, and that's going to be minus 5x squared and plus 25x, and then plus c. And now the final one is going to be number 11. So we have 4x to the negative 2/3 power, and then minus 2x to 5/3 power. So what we're going to do is x, and then we add 1 to that. So we add 1, we're going to have 1 over 3, and divided by 1 over 3, which means multiplied by 3. So we're going to have 12x to 1/3 power minus x to the 8 over 3 power divided by 8 over 3, which means multiplied by 3 over 8. So it'd be 3 over 4. Or it would be 6 over 8, but if you simplify that, it's 3 over 4. And that would be plus c. So let me just isolate it there. So that would be your answer for number 11. And that's your answer for all of these. Alright, so I want you guys to try number 12, 14, 16, and 17. For these, a good advice would be that you want to rewrite the function as exponents that are fractions, so that you can antiderive it better actually, or even decimals works as well. So you want to multiply it out, divide it out first as exponents of fractions or negative exponents, and then antiderive it. So you can pause the video and try that out. Alright, so let's take a look at number 12. So number 12 is h of z is equal to 3z to 0.8 power plus z to negative 2.5 power. We're not going to change it to a fraction because there's really no need, so we'll just write it as it is. So if we find the antiderivative, we're going to have z to the 1.8 power and times 3 divided by 1.8 plus z to the negative 1.5 power and divided by negative 1.5. And we could simplify this further, but we'll just leave it like this. You could simplify it in a way in which the decimals, or you don't have like numbers with decimals in them, and rather whole fractions, but you could leave it like this. And now number 14, what we're going to do is multiply it out first before we find the antiderivative, and we're going to put the exponents in terms of fraction. So we have 2 times radical x, and radical x is, we can write it up here, radical x is equal to x to 1/2 power. That's a good way to rewrite it. So we have 2x to the 1/2 power minus x to the 3/2 power, because it's x to 1 power times x to 1/2 power. And when you multiply them together, you add the exponents. and then plus 6x to the 5 half power. And now we find the antiderivative, which is going to be x to the 3 half power times 4 over 3, as we minus x to the 5 half power times 2 over 5. One good way to think about it is however the exponent is, just flip it and multiply it. And we're going to have plus x to the 7 half power times 12 over 7. And you would also put a plus c at the end, so we could just fit a plus c right there. And what was it? Over here, this would be our answer for number 14. And now we look at number 16. So number 16, we're going to rewrite it as a fraction. The exponents as a fraction. So we have 5 to the 1/4 power. And then we have plus x to the 1/4 power. And what we have here is 5 to the 1/4 power. Don't get tricked, but it's just a constant. So what you would do is just add x to it. You wouldn't add anything to this exponent. This would just be a number because it's a constant. So you would add x to the constant. So if we find the antiderivative, we're going to have, we could also rewrite it as just, the original form, fourth square root of 5. So we would have fourth square root of 5 times x plus x to the 5 over 4 power times 4 over 5. And you have plus c as well. And that would be our answer for that. And now we move on to number 17. So number 17, we're going to be dealing with some negative fractions here. So if we rewrite it out, we're going to have 2 over 5 times x to the negative 1 power minus 3 times x to the negative 2nd power. And now we want to find the antiderivative of this. So what we actually could have done is just kept it at 2 over 5x. Because if you remember, ln of x is, the derivative of that is 1 over x. So if you find the antiderivative of this, or if you break it up, it would just be 2 times 1 over 5x. And 1 over 5x, antiderivative of that is going to be ln 5x. So for the first part, actually, you didn't need to put the negative exponent, or we didn't need to put it. But the answer to that would be 2 ln 5x. And you would put the absolute value, because when you find the antiderivative into the ln, you can't have a negative number in there, so it has to be absolute value, 5x, and then that's going to be minus x to the negative 1 power, and 3 over negative 1, but negative 2 negatives is a positive. And let's rewrite it out, all this. So we have 2 ln absolute value 5x, and that's going to be plus 3 over x. And that is going to be our final antiderivative for number 17. Alright, so that was essentially antiderivatives, and antiderivatives is, the basic rule of thumb is just the opposite of derivatives. Whatever you would find to derive a function, just do the opposite of it. And it's a good rule to memorize the antiderivatives of like trig functions, and the variables with the exponents, you just add one and then put it over the new exponent. And as well, the ln, it's also a good rule of thumb to know 1 over something is the antiderivative is going to be ln of whatever's on the denominator of that. So yeah, that's basically it.